Hello everyone and welcome back to the channel. I'm going to be making a series of videos where I'm going to be explaining the concepts of probability and statistics using Microsoft Excel. Today's video is the first part of the series where we are going to get started with the concepts of probabilities. So let's dive right into it. So what is probability? Probability is nothing but a numerical value or a percentage that is assigned to a chance that a specific outcome may occur. Let's take a look at this with an example. So, let's say with the case of a coin toss. Can you pause the video and list down what are the possible outcomes of the coin toss? Alright. So, the outcomes are I can have two outcomes with the coin toss, either a head or a tail. So, in the world of probabilities, we have a concept called as sample space. So, sample space is nothing but it's a set of all the possible outcomes that can occur in the experiment. So again, the possible outcomes that can occur in the experiment is here h, comma, t. So the sample space in this experiment is h, comma, t. We also have another concept called as event. So what is an event? So an event is a specific outcome or outcomes to which a probability is assigned. Okay, so let's take a look at this. So the probability of getting a head, if I want to find that, in this case the event space is consist of h. Okay. Now to understand this more clearer, let's take a look at this example with a case of a roll of a dice. Pause the video and see if you can come up with this on your own. Alright. So in this case, the outcomes for the roll of a dice are, as you might have guessed, 1 to 6. Okay. 1 to 6 is the outcomes. What are the sample space? Sample space, all the possible outcomes of this experiment, that is 1, 2, 3, 4, 5, 6. Now let us understand what is event in this case. So here in this case, say I want to find out what is the probability of getting a number which is greater than 4 when I roll the dice. So getting either a 5 or a 6 when I roll the dice. So in this case, the event space will be, as we discussed, the outcomes to which a probability is assigned. So I want to find what is the probability of getting a 5 or a 6 or getting a number greater than 4. So in this case, it will be 5 and 6. Alright. Now, let us find what is the total number of outcomes in each experiment. In this case, the total number of outcomes can be found out by using the count A, where you are counting alphanumeric values. So the total count is 2. Okay, and I want to find the probability of getting a head or a tail. So let us write here probability. Okay. But before we try to find the probability, we have to make certain assumptions. The assumptions are that the likelihood, okay, the likelihood of either a head or a tail occurring in this experiment is same or equal. Okay. So there's equal likelihood of getting a head or a tail because the coin is properly designed and the likelihood of getting either a head or a tail are the same. And also in the experiment, at least one outcome will happen. That means I will either get a head or I will either get a tail or a head every time I toss the coin. And also we have to make another assumption that in this case, at least one of the outcome will happen. It's not possible that I will not have either a head or a tail. Okay, so at least one outcome will happen. In this case, I can find the probability by using the formula equal to 1 divided by the total number of outcomes. Let's fix this, hit F4 and hit enter. So you can see here there's a 50% probability of me getting a head or a tail provided the assumptions are met. Okay. Now let's take a look at the second experiment. Pause the video and try to see if you can guess the answer on your own. Okay. So in this case, the probability is, again, we make the same assumptions. The likelihood of getting either a 1, 2, 3, 4, 5 or 6 for every roll of a dice are the same. Okay. Because we assume the dice is properly designed, and in this experiment, the likelihood of each event is the same. Okay. And the events are mutually exclusive. That means I cannot get a 1 and a 2 together. They are all exclusive. I'll get only one number. And also the one event will happen. At least one event will occur, or at least one outcome will occur. In this case, the probability is equal to 1. Let's do the count of the total number of outcomes first, equal to count A. So the size of the sample set is 6. So the probability is equal to 1 divided by hit F4, fix this, hit enter. Okay, you can make this into percentage, and it's 16.67% probability of getting a 1 or a 2 or a 3 or a 4. So in both these cases, we have made assumption that the likelihood is same and the events are mutually exclusive, and at least one event will happen. Now let's take a look at a case where the likelihood of a specific outcome may not be the same. Okay, say I have certain students, 10 students giving an exam. Okay, so say I have 10 students giving an exam. Okay, and the outcome, let's assign random outcomes. Okay, let's say finishing test in hours. So let's assign random outcomes. Say student 1 finishes the test in 1 hour. Okay, student 2 1 hour, student 3 takes 2 hours, and the rest of the students take exactly 3 hours to finish the test. Okay, so in this case the outcomes are different. So let us find the outcome. So the outcome of a student, so the likelihood of an outcomes are different in this case. So in this case the likelihood of the outcomes are different. So you can see here, if you look at the data, the likelihood of the student finishing the test in exactly 1 hour is lesser as compared to the likelihood of the student finishing the test in 2 hours or 3 hours. Okay, so let us find the outcomes here. So outcomes. So there are 3 possible outcomes here: 1, 2, or 3 hours. Okay, and let's do the count. Okay, so let's do the count ifs here. Count if, and I'm going to count this entire range. Let's hit F4 to fix this, comma, and I want to count 1. Okay, let us drag this down, double click here. Okay, and now you can see is the likelihood of the outcome of a student finishing the test in exactly 1 hour, here the count is 2. Okay, so it is lesser as compared to the likelihood of the student finishing the test in 3 hours, because 5 students finish the test in 3 hours. So in this case, how to find the probability? So again, what are the total number of outcomes here? Let us do count A. Okay, sorry, we have to do sum in this case. Okay, we are summing up. Okay, so the total number of outcomes in this experiment is 10 because there are 10 students. Okay, and now let us see how to find the probability. So here is equal to, let us do this number, okay, divided by here. Let's fix this, and let's copy it down, and now let's make it into a percentage. Okay, so here you can see there's a 20% probability of a student finishing the test in exactly 1 hour, 30% probability of a student finishing a test in exactly 2 hours, and 50% probability of a student finishing a test in exactly 3 hours. So here you can see the likelihoods of the outcomes are not the same. In this case, the past outcomes matter, the past data matters. In this case, the past data doesn't matter, as the likelihood of every outcome happening is the same. Here it's not the same. So in this case, the past outcomes matter. Okay. Now, if you paid attention, I use the word the probability of the student finishing the test in exactly 3 hours and not in 3 hours. There's a special meaning to that, why I used it in exactly 3 hours, and we'll see that when we talk about the next concept in the next video. So stay tuned to the channel and subscribe to my channel if you like the channel, and leave a comment on this video, and we'll see the next topics in the next video. Thank you.